Okay, so let's jump right in. Before we can even start talking about wings and engines, we all need to be speaking the same language. This is the language of physics, the fundamental rules that make flight possible.
And it all starts right here with energy. Simply put, it's the capacity to do work. For our purposes, we're going to focus on its two main flavors: potential energy, which is stored, and kinetic energy, which is the energy of motion.
So potential energy is just waiting to be used. Think of a stretched rubber band. The jet fuel sloshing around in an airplane's wings, that's a perfect example of chemical potential energy. And you know what else is? The plane's position itself. Just by lifting it off the ground, you're storing energy in it.
And get this, the scale here is just mind-boggling. If you take a Boeing 747 that weighs 450,000 pounds and lift it just 4 feet in the air, it already has 1.8 million foot-pounds of potential energy. That's an incredible amount of stored power from just a tiny change in height.
Now, once that plane starts barreling down the runway, its potential energy starts turning into kinetic energy, the energy of motion. And here's where it gets really interesting. Check out that formula. The key part is that velocity is squared. What that means is, if an airplane doubles its speed, its kinetic energy doesn't just double, it quadruples. So yeah, when it comes to an airplane, speed is everything.
Okay, let's clear something up real quick. Work versus torque. They sound similar, but they're different. Work is basically moving something over a distance, like lifting a box. Torque, on the other hand, is a twisting force, which is absolutely essential for things like the spinning blades inside a jet engine. So if work is getting a job done, then power is all about how fast you get it done. It's not just about applying the force, it's about the rate. Time is the secret ingredient that turns simple work into powerful action.
And how do we measure all this power? Well, we often use horsepower. 1 horsepower is basically the power it takes to lift 550 pounds 1 foot off the ground in just 1 second. It's an old school unit, yeah, originally based on actual horses, but it's still the benchmark we use to talk about the immense power of modern aircraft engines.
All right, one last quick one before we move on. Speed versus velocity. Speed, that's just a number on a dial, right? How fast you're going. But for a pilot, direction is absolutely critical. Velocity includes that direction. Saying you're going 150 miles per hour isn't enough. You need to know you're going 150 miles per hour due north.
Okay, so we've got the lingo down. Now let's look at how a plane actually gets moving. We're diving into how planes create that forward push. And for that, we're going to need a little help from an old friend, Sir Isaac Newton.
So, Newton's first law, it's all about inertia. That huge airplane sitting on the tarmac, it really wants to stay right there. To get it moving, you need a massive external force to overcome that inertia. It's literally the same principle a magician uses to whip a tablecloth out from under a pile of dishes. Their inertia keeps them in place.
So where does that massive force come from? Well, it comes from Newton's third law. This is maybe one of the most beautiful and powerful laws in all of physics, and it's pretty much the secret sauce behind every single jet engine. For every action, there's an equal and opposite reaction. Simple as that.
So here's how it works, plain and simple. A jet engine's main job is to perform one heck of an action. It sucks in a gigantic mass of air and blasts it out the back at incredible speed. That right there, that's the action. And the equal and opposite reaction, the engine and the entire airplane connected to it, gets pushed forward with the exact same amount of force. And that powerful forward push, that's what we call thrust.
Okay, so thrust is pushing us forward. Awesome. But how in the world do we get off the ground? This brings us to what is, for my money, the most magical part of this whole thing. The secret of lift, and how a cleverly shaped wing can completely conquer the force of gravity. I mean, really, let's just ask the question. How does that simple curved shape of a wing create an upward force so powerful it can hoist a 450,000-pound jet into the air? It seems impossible, right? But the answer is actually found in a very simple relationship between how fast air moves and the pressure it exerts.
And this little gadget right here, this explains everything. It's called a Venturi tube. Now watch. When air flows from the wide section into that narrow throat in the middle, it has to speed up to squeeze through. And here's the kicker. Here's the magic trick. As that air's velocity goes up, its pressure goes down. Faster flow, lower pressure. Remember that.
So that whole effect we just saw, it has a name. Bernoulli's principle. And an airplane wing, well, it's basically half a Venturi tube. It's engineered, it's designed to have that curved top and a much flatter bottom. This shape forces the air going over the top to travel a longer path. And because of that, it has to travel faster than the air moving underneath.
So what's the result of all this? Well, you get that faster moving air over the top of the wing, which creates a zone of lower pressure. At the same time, you've got slower, higher pressure air underneath. That higher pressure has nowhere to go but up, and it literally pushes the wing into that low pressure zone above it. And bam, that, my friends, is lift.
All right, we've got thrust pushing us forward, we've got lift pushing us up, so let's put it all together in our final section and see how this becomes a delicate, powerful dance of forces that makes controlled flight a reality.
You see, an airplane up in the sky, it's never just dealing with one thing at a time. Its true path over the ground, vector c here, is actually a combination, the sum of its own velocity from the engines and the velocity of the wind. Pilots are constantly doing this math in their heads to figure out where they're really going. And really, at the end of the day, it all boils down to this: the four fundamental forces of flight. You've got thrust, from Newton's third law, pushing the plane forward. Fighting against that, you have drag, which is just air resistance. Then you have lift, from Bernoulli's principle, pushing the plane up. And always fighting against that is the pull of gravity, its weight. Flying isn't about beating gravity, it's all about finding that perfect, delicate balance between all four of these forces.
So, we've unpacked the incredible classical physics that allows these giants to fly. But, it leaves us with this huge, fascinating question for the future. As we push towards things like electric jets, hypersonic travel, and who knows what else, what new principles of propulsion and aerodynamics are just waiting out there to be discovered, ready to completely redefine what it means to conquer the sky?